Hey everyone, we're going to look real quick at numbers 1 and 2 in section 3.4, just some easy get you going rate of change problems. The first one is to find the rate of change for the area of a square with respect to its side S, okay, when S is equal to 9. We're not given any units with this problem, but I'll talk about that in a minute. So this, again, remember, is the phrase that basically means what for calculus? Means the derivative, right? The rate of change of our function being the area of a square, I underline that, with respect to, and then side length S. So the dependent variable, the function we're trying to find the derivative of, is the area of a square, and we're doing that with respect to S. Okay, so we are looking for if A is the area and the side length is S, I expect everyone to know the relationship between area of a square and its side length, and that is that the area of any square is its side length squared, right? Area of a rectangle is length times width. For a square, length and width are equal, so you get S squared. So you should know that fact from geometry. And so what are we looking for? The derivative, right, is the rate of change. So the derivative of the area, A, with respect to S. So that's dA ds. That's the derivative of A with respect to S. That's the Leibniz notation for the derivative, and that's what the derivative represents. So that's what we're looking for. And if I told you what the derivative of A is with respect to S, I hope everybody says that's the easiest thing I can ever do, right? The derivative of S squared by the power rule is just 2S. So we are going to now evaluate that derivative. Remember, when we have a Leibniz notation, we use this vertical line afterwards, meaning evaluated at what? S is 9. So I simply replace S with 9. Of course, I get 18. Now, what are the units of the rate of change of the area with respect to side length S? Well, they didn't give us any units for area. So the basic idea will be, it would be area units, and area units are square units per what? Side length units, which are just linear units or units. So it's the units would be square units per unit increase. In other words, 18 square units of area increase, right, per unit area, unit length increase in side length. So for instance, if the area, let's say the side length was given in inches, then the area would be square inches. Our units would be square inches per inch. In other words, that would be the number of square inches the square area would increase for every inch increase in the side length. Okay, so basically, as far as the math goes, pretty easy. Derivative of S squared is 2S, plug in S equal 9. Number 2 is very similar. Find the rate of change of the volume of a cube with respect to the length of its side S when S is equal to 9. Well, I expect you to know, if again, V is the volume. I don't think they said V is the volume, so V is the volume of this cube. Again, they don't give us any units, but we'll address that in a second again. So the volume would be what? Side length cubed. So I expect you to know this. I expect you to know the area of any box, any rectangular solid, is its length times width times height. And in a cube, the length, width, and height are all equal, right, to that side S. So S cubed. So we're just going to find the derivative of V with respect to S, which again, piece of cake, derivative of S cubed by the power rule is 3S squared. So I evaluate that when S is 9, and replacing that with 9, I get 3 times 9 squared. 3 times 81 is 243. The units here are cubic units per unit increase because volume would be cubic units. So again, if S were 9, say, inches, then the volume would be cubic inches, and we would say 243 cubic inches per inch would be the units. Okay, so rather simple as far as math goes, but a little tricky. You do need to know some basic geometry formulas. There are some more advanced geometry formulas given to you on that algebra geometry trig help sheet, so you want to take a look at that as well. Okay, hope this is helpful for you.